Dear students, today I am going to discuss the first 20 questions of paper 2021. Question number 1. Which of the following pairs of physical quantities have same dimensions? They are asking about the dimensions, but it's better you can consider the units because units are more familiar to you than dimensions. First answer, stress and strain. Stress is force over area and strain is extension over original length. Stress has a unit but strain doesn't have a unit. So the dimensions of stress and strain are not same. Answer 2. Work and energy. The unit of work is joule. Unit of energy is also joule. Work and energy both have same units. So the dimensions of work and energy is also same. The answer is 2. Not necessary to go for the other answers. Answer is 2. Question number 2. In a vernier caliper, a length of 19 main scale divisions is equally divided into 20 vernier scale divisions. What would be the length of a main scale division in order to have a least count of 0.025 millimeter? If you check the notes, you can find that least count of a vernier caliper is given by this equation. Least count is equal to length of a main scale division. Length of a main scale division divide by the number of vernier scale divisions. Vernier scale divisions. Now here in this question, least count is given, that is 0.025 millimeter. 0.025 millimeter. Length, they are asking for the length of a vernier scale division. We put that as x divide by number of vernier scale divisions are 20. So x is 0.025 multiplied by 20. Answer is 0.5 millimeter. Answer 1. Question number 3. Bending of light when passing a sharp edge. Bending of light happens in refraction and also in diffraction. But in refraction, light bends when the light passes from one medium to another. Here in the question, bending of light when passing a sharp edge. So that is diffraction. Diffraction happens when the light passing a sharp edge or when the light passing through a small gap. Here the answer is 4. Question number 4. If no external forces act on a system, which of the following is conserved in any type of collision? When they are talking about the collision, immediately that linear momentum comes to your mind. If there is no external forces, total linear momentum is conserved. That is purely, this question is from theory. Answer 5. Total linear momentum is conserved. Question number 5. The mean kinetic energy of an ideal gas depends on its. So that is also from theory. It is absolute temperature. Answer 4. Question number 6. A block of mass capital M moving at velocity 2v on a flat frictionless surface makes a perfectly inelastic collision with another block of mass capital M moving at velocity v along the same direction. What is the velocity of the first block after the collision? Now this is a perfectly inelastic collision. So both the masses move together after the collision. Let's look at the screen. Mass capital M moves at a velocity 2v. The other mass, same capital M, moves at a velocity v. Before collision, they move as in the figure, and then they collide and stick together because it's a perfectly inelastic collision. They stick together. The total mass is now 2m. We take that final velocity is v dash. Now, using the conservation of momentum, before collision it is m into 2v plus m into v equal, after collision, 2m into v dash. Here 3mv equal 2m v dash, 3 over 2v equal v dash. Answer is 4. Question number 7. The breaking strain of an aluminium rod is 0.2%. What is the minimum cross-sectional area of the rod to withstand a force of 3.5 into 10 to the power 3 Newton? Young's modulus is also given. We'll write down the equation for Young modulus. Young modulus is equal to stress over strain. Stress is force over area. Strain is extension over original length. And in this question, it is given that breaking strain of an aluminium rod is 0.2%. 0.2% strain. Strain is 0.2%. That is, the ratio strain is extension over original length, that is E over L, is 0.2%. That is 2 over 0.2 over 100. So E over L is 0.2 over 100. Now we substitute the values. 7 into 10 to the power 10 equal, force is 3.5 into 10 to the power 3 divide by area divide by 0.2 into 100. Here 3.5, 2 times of 3.5 is 7. 10 to the power 3. Deduct 3 from this. 7. Then you have 2 times 10 to the power 7 equal 1 over A divide by 0.2 over 100. That is 1 over A into 100 over 0.2. A is 100 into 0.2 into 1 over 2 into 10 to the power 7. Then answer 100 and here deduct 2, then you get 5, that is 1 over 0.4 into 10 to the power 5, 10 to the power minus 5, that is 10 over 4 into 10 to the power minus 5, 10 over 4 into 10 to the power minus 5, that is 2.5 into 10 to the power minus 5. Answer 4. Question number 8. What is the charge of a down quark? That you have to remember. Answer is 3. Minus 1 over 3 E. Answer 3. Question number 9. The figure shows a composite string made of same material. The cross-sectional area of string B is twice that of string A. The other end of the string B is attached to a fixed wall. If both strings are under same tension, which of the following graphs best represents the variation of speed V of transverse waves generated in string with distance x? Both A and B strings have same lengths. Lengths are equal. But cross-sectional area of B is twice that of cross-sectional area of A. Then the mass of the B string is twice of the mass of string A. We write down the speed of the wave in a string. It is given by T over M square root. T is tension, M is mass per unit length. Another, both A and B strings are in equal lengths. So the mass of B is twice than mass of A. That is, mass per unit length of B is twice than mass of unit length of A. That is, if the mass per unit length of A string, for A string, we take mass per unit length is m, and then for B string, it is 2m. And we write down the equation for the speed of the wave for both strings. For A, it is T over M square root. For B, it is T over 2M. We take the ratios of VA and VB. Equal T over M this is T over M divide by T over 2M square root. That is T over M multiplied by reciprocal 2M over T square root. That is T over M into 2M over T square root. T cancel, MM cancel, equal root 2. That is VA So VB equal root 2. Then you can get VB from that. VB equal 1 over root 2 VA. One over root 2 is, find 1 over root 2 and into VA. Anyway, one over root 2 is 0.7. 0.7 VA. So VB is 0.7 times of VA. Now think, look at the answers given. VB is 0.7 times of VA. That is VB is smaller than VA. In answers 1 and 2, VB is smaller than VA. This is for VA, for the A string, and this is for the B string. VB is smaller than VA. VA, VB. Here VA, VB. VB is smaller than VA, but here VB is 0.7 times of A, not half, 0.7. So the answer must be, if it is half, 0.5, if VB is 0.5 VA, this the answer would be this. Because this height, when you compare this height and this height is half of this height. But VB is not 0.5 VA, not half of VA, it is 0.7 VA. So the answer is this second one. Question number 10. The given circuit is equivalent to it is a NOT gate. So nothing to think about that. It is from the theory, it's a NOT gate. Question number 11. An object is placed in front of a concave lens as shown in the figure. The path of the refracted rays emitting from point A of the object are. We draw the ray diagram on the screen. Here is the concave lens, principal axis, and the focus, focal point, object, if a ray, this is the point A, if a ray coming parallel to the principal axis, it will refract as it coming from the focal point. So this is the ray P given in the paper. And if a ray passing the center, it will go without deviation. So that is R. If a ray coming focusing the focal point, it will go parallel to the principal axis. This is Q. So answer 3 3 ways are there for the condition they are asking P, Q and R. Answer is 4. Question number 12. The displacement time graph for the motion of an object is shown in the figure. The corresponding velocity time graph would be best represented by. When you take the first part of the displacement time graph, it's a curve and it shows the motion is a deceleration. So deceleration is shown by the answers 3 and 5. For the first part, deceleration is shown by the answers 3 and 5. And after some time, it's stationary, no displacement, stationary. That is, velocity is 0. So here in both 3 and 5, velocity is 0 here. And after that, displacement increases. Displacement is also to the same direction, not to the other side, not to the opposite side. It is to the same direction, because always displacement increases. Here increases. This part also increases. So it's moving with an acceleration now to the same side. Displacement is positive. So then the velocity is positive and acceleration. So it is not 5, then answer 3. Question 13. An object A moving in a circular path at a uniform angular velocity is shown in the figure. The variation of displacement x and velocity v of the point P of projection of the object on the x-axis with time t is best represented by. Look at the diagram I have drawn here. My diagram is not very nice because it is difficult for me to draw nice diagrams with this pen. Now look at the point A. A is moving anti-clockwise around the circle, and point P is the projection of A on x-axis. While A is moving on a circle anti-clockwise, P moves from the starting point. P moves from this point to the left corner of the circle and coming back to the original position again. Now you can see when at the starting point, when A is on the x-axis, P is also on the x-axis. Then at that time, P is having its maximum displacement. So initially when the time is 0, P is having its maximum displacement. Now when you compare the answers given, 1 and 3 graphs are showing maximum displacement when time is 0. Maximum displacement when time is 0. 1 and 3 graphs are according to that condition. Now we have to, definitely we can decide the answer be either 1 or 3. Now we think of the velocities. At P, when P is at the starting point, its velocity, it is at the maximum displacement, so its velocity is 0. When it's coming to the equilibrium position, it should have the maximum speed. So that is showing by the answer A. But the velocity at the beginning, velocity is negative in the graph A, graph 1, because the direction of the velocity is to the left side, not to the positive side of x, it is to the left side. So it should be a negative value. V value the velocity must be a negative at the beginning. So answer is 1. Look at the diagram again. Here in the first diagram, the water has risen up 2 centimeter in the capillary tube. The pressure at this level, pressure by the liquid column, water column, is given by H rho G, and H is 2 centimeter. Now here in the second diagram, the capillary tube is tilted, but nothing, the atmospheric pressure is not changed. The liquid is also same. So the pressure at the same level, at this level, must be equal to the same pressure as in the figure 1. This pressure in 1 and 2 at this at the surface level of the water must be same. To get the same pressure at P, this H must be 2 centimeter, because here by 2 centimeter it gives this pressure. So in 1 and 2 the pressure, liquid pressure, must be same. So H here also must be 2 centimeter. So that is L is the length of the water column in the capillary tube here. H is equal to L, this angle is 60 and this angle is also 60, L cos theta. H is 2 centimeter, L cos theta is half, cos 60, theta is 60, theta is 60, so cos 60 is half, L is 4 centimeter. Answer is 5. Question number 15. They are asking about the true statements regarding the moment of inertia of a body. Moment of inertia of a body is given by the equation mr squared. M is the mass of the object and r is the distance to the mass distribution from the axis of rotation. And we consider the answers given. It depends on the mass of the body. Yes, it's right. It depends on the mass distribution of the body. Yes, it R is showing that the distance to the mass distribution from the axis of rotation. C, it depends on angular velocity of the body. No, nothing. C is wrong. A and B are true. Answer is 3. Question number 16. A liquid of density rho flowing at speed 3v through a horizontal tube of cross-sectional area A strikes a vertical wall perpendicular and flows down along the wall without recoil. The force exerted on the wall by the liquid. Let's draw a diagram for this. Horizontal tube, cross-sectional area is A, and the speed of the liquid inside the tube is 3v. We take that as u. And density of the liquid is rho. Liquid flows inside the tube and they strikes on a vertical wall. After striking the wall, this water flows down. Now the velocity of the water is downwards after hitting the wall. Initially it was horizontal and final velocity of the water is vertically downwards. Now we want to find the change in momentum to find the force exerted on the wall. The force is given by rate of change of momentum, that is mv minus mu divided by time. final velocity to the horizontal is 0. So this is 0 minus mu over t. That is for the force on the water. So they are asking for the force exerted on the wall is same, but it's positive, mu over t. We want to find this mu over t. M is not given directly. So the mass is volume into density. Consider the length of the tube is L, and then volume is AL into density is rho. Now when you compare this equation, F is mu over T, and we can write F equal m over T into U. So this is m is AL rho. If m over T is A L over T into rho. L over T is the velocity of the liquid, distance divided by time. That is 3V. So then A into 3V into rho. We substitute it here. M over T is A into 3V into rho, and U is 3V. So you get 9 rho A V squared. Answer 2. Question number 17. 2-point charges plus 4q and minus q are fixed at a distance x apart as shown in the figure. Another point charge plus q does not experience a net electric force when it is kept along the same line at distance y from minus q. They are asking for the relation between x and y. They are saying this plus q charge does not experience a net electric force. That is, there is no electrical field strength. Since there is no electrical field strength, it cannot experience a force. Now we check for the electric field strength due to these two charges. The electric field strength is given by the equation Q over 4 pi epsilon naught r square. Now we check for the electric field strength at this point due to plus 4q charge. We say that electric field strength is E1. E1 is equal to, now Q is plus 4q divided by 4 pi epsilon naught. The distance between the 2-point charges plus 4q and plus q is x plus y. Distance is x plus y square. And the direction of E1 is to this side, because this is a positive charge and this is also a positive charge. Anyway, the electric field strength at this point is to the right side. So E1 is in the direction to the right. Then we get the electric field strength due to minus q at this point. So it is E2. E2 equal minus q divided by 4 pi epsilon naught. Distance is y square. The direction is negative, to the negative direction, E2. E1 is to the right hand side direction, E2 is to the left hand side direction. Now E1 must be equal to E2 for the condition that the net electric field strength at this point is 0. That is 4Q. We take the magnitude of the two electric field strength, 4Q over 4 pi epsilon naught x plus y squared equal, we take the magnitude Q over 4 pi epsilon naught y squared. We took only the magnitudes because we know the directions of the electric field strength. Now Q cancel, 4 pi epsilon naught cancel, and here you get 4 over x plus y square equal 1 over y square, and you get 4y square equal x plus y square. You can find the relation between x and y by using algebra. Otherwise, simply you can solve this. Left hand side you have 4y squared, and right hand side x plus y squared. If x is also y, y plus y square is 4y square. So the answer must be 1, x equal y. When x equal y, simply you can get the simplify this equation. 4y squared equal to 4y. Right hand side and left hand side both have 4y squared if x equal y. So answer is 1. Question number 18. A block placed on a horizontal frictionless table is attached to mass m by a light inextensible string that passes over a pulley as shown in the figure. When released from rest, mass m and the pulley accelerates. If the tensions in the sections in the string are T1 and T2 as marked, which of the following is true? Now they say that simple m is accelerating. It is accelerating downwards. To accelerate downwards, there should be a downward resultant force. To get a downward resultant force, mg, the weight of the mass mg must be larger. So mg must be larger than T1. T1 is upward force on the m. Mg is the downward force on the m. To accelerate m downwards, mg must be greater than T1. And they say pulley is also accelerating. Now T2 is to this direction on the pulley, and T1 to the downward direction. If you think of the two forces on the pulley, to turn this with an acceleration, T1 must be larger than T2. Answer is 5. That is, mg must be larger than T1, and to accelerate the pulley to this direction, that is clockwise direction, T1 should be greater than T2. Answer is 5. Question number 19. The variation of product PV of pressure and volume with pressure P for a fixed mass of an ideal gas at constant temperature is best represented by. Think of a fixed mass. Fixed mass of gas, pressure P and volume V and temperature T. For a ideal gas, we know that PV over T is constant. for a fixed uh, mass of gas. PV over T is constant. And they say temperature is also constant. T is constant. Therefore, PV is constant. Since T is constant, PV is constant. And if P increases, then V decreases to make the product constant. Anyhow, even though the pressure P increases, volume adjusts to get the product of PV constant. So even though the P is increasing, PV is constant. Answer 5. Question number 20. The diameter and mean density of Jupiter are 11 times and 1/4 times respectively to that of Earth. If the gravitational intensity at the surface of the Earth is 10 Newton per kilogram, what is the gravitational intensity at the surface of Jupiter? Equation for gravitational intensity, simple G equal capital G M over R squared. We use this equation for Earth, gravitational intensity of Earth at the surface of the Earth equal G M over R squared. That is G, capital M, mass is volume into density, divide by R squared, equal G, volume is 4 by 3 pi R cube and density is rho, divide by R square, and you get capital G into 4 over 3 pi, this R cube and 1 R remain there, R rho. By looking at the derived equation, we can write the gravitational intensity of Jupiter G dash equal capital G into 4 over 3 pi. Now R, Jupiter's R, we take R dash, and Jupiter's density rho dash. Diameter of Jupiter is 11 times of diameter of the Earth. Then radius of the Jupiter is also 11 times of radius of the Earth. Therefore, we can write G dash equal capital G into 4 over 3 pi R dash is now 11 times of R. R dash is 11 times of R into rho dash is 1/4 of rho. We divide G dash by G equal capital G 4 by 3 pi into 11 R into 1/4 of rho, divide by G 4 over 3 pi R into rho. G cancel, 4 by 3 cancel, pi cancel, R cancel, rho cancel. Then we have G dash over G equal 1 over 4 divided by here 1. That is, sorry, 11 into 1 over 4 divide by 1. And we know that G dash over G is 10, given G as 10 equal 11 over 4. Then we have G dash equal 110 over 4. Answer is 27.5. Answer 1.